Welcome to 5.1 Trig Identities. An identity is when both sides of an equation are equal and they're both defined. A trig identity is one that involves some trig. So the reciprocal identities are just something that we've talked about, but we haven't really put into words. We already know that sine and cosecant are reciprocals of each other. Be careful that you don't say inverse. I know a lot of us have mistakenly used that term. And now we've studied sine, cosine, and tan inverse. We know that it's not, cosecant, secant, or cotangent. Anyway, these are reciprocals of each other. Cosine and secant are reciprocals, and tan and cotangent are reciprocals. So we can just officially write these out just like this. We could similarly write that the cosecant is the reciprocal of sine. 1 over something doesn't necessarily mean you have to write 1 over it. It just means take the reciprocal. Same thing for here. And lastly, the cotangent of any angle could be written as 1 over the tangent or the reciprocal of tangent. All right, let's do some examples. These are pretty simple. I'm just working straight through the book basically. So I'm doing the guided practice. The examples are for you to look at. Me going through them is not going to be as helpful. So I'm going to do the guided practice. So in the first example box on page 312, 1a, says that if the secant of x is 5/3, what is the cosine? All right, well, technically, secant is defined as 1 over the cosine. But please don't write 1 over 5/3. That's just unnecessary. We don't need to do that. All we need to do is take the reciprocal. So the cosine is 3/5. It is worth pointing out that let's say the secant was negative, the cosine would also be negative. All right, if you need to pause here and make sure the reciprocal identities are written down, go ahead. We're going to move on to quotient identities next. Okay, the quotient identities deal with the fractions here. So quotient is, after all, just a fraction. So we already know that tangent equals sine over cosine. And so this is just an alternate way to write tangent. Yes, we can write tangent as 1 over cotangent, right? But we can also write it in terms of sine and cosine. Sine and cosine are basically like the building blocks of the trig world. Yes, we have 6 main trig functions or trig ratios, right? Cosine, sine, tan, secant, cosecant, and cotangent. But sine and cosine are those main 2. They are the y and the x of anywhere on the unit circle. And so they're kind of like the building blocks of the other 4. So we can alternately write tangent as sine divided by cosine. Similarly, how do you think we can write tangent or cotangent? We can write it as cosine divided by sine, since it's just the reciprocal. So there are, a few different ways to write them. These are called the quotient identities because they are quotients. All right, let's take a look at an example. I am now on the same page. Example 2b. All right, this tells us, hey, let's say, 1b. The guided one that doesn't have the answer there. All right, this one says if the cosecant, and that says beta, that's hard for me to draw, so I am just going to stick with theta. The cosecant is 25 over 7, and the secant is given as 25 over 24. Our goal is to find the tangent. All right, so if we think about the information that we're given, right, we know that the cosecant is the reciprocal of sine, and the secant is the reciprocal of cosine. And so since sine and cosine can allow us to find tangent, we can write these as reciprocals using those reciprocal identities and then put them into a quotient to find the tangent that we're looking for. So that's our goal, is to find tangent. So let's write out the information that we know from this. The information that we know from the cosecant being 25 over 7, cosecant is reciprocal of sine. So we know that the sine would be the reciprocal, so 7 over 25. Similarly, we know that since the secant is 25 over 24, that means its reciprocal cosine is 24 over 25. Cool. All right, that helps us find our goal of tangent, right? Okay, the tangent is the sine divided by the cosine, so it's 7 over 25 divided by 24 over 25. And again, this is called a complex fraction. It's a fraction within a fraction, which can sound scary, but I promise it's not. And when we have something similar in the top and the bottom, remember, we can cancel those out. So this is 7 over 24. Cool. An alternate way of thinking about this is if you're thinking about SOHCAHTOA, right? Remember how we know sine is opposite divided by hypotenuse, and cosine is adjacent divided by hypotenuse. Well, 25 is the hypotenuse then. This is opposite, this is adjacent. Tan is TOA, opposite over adjacent. So that's kind of an alternate way you can look at this. If that just confused you, then just ignore me. You guys know how sometimes I go off on tangents. Ha. Okay, bad jokes aside, make sure you have this written down. And next we're going to go into the really fun identities, the Pythagorean identities. All right, this is kind of like the coolest one. And it's something that I've referenced before and even put as like part of your take-home test. I asked you to like pick an angle and prove that sine squared plus cosine squared equals 1. Let's think about why that is real quick. The unit circle, there's like a tool to draw a circle, but I'm not that good at this yet, so I'll get there. So here's my like decent circle. Anyway, we know that the unit circle obviously is called a unit circle because it has a radius of 1, right? So we know that since its radius or the hypotenuse is 1, this was an xy coordinate point, right? And the equation of a circle is this. Also, don't worry about writing this part down. I'm just doing some cool derivations for you. All right, that's the equation of a circle. R is the radius. H and K are the coordinate points of the center of the circle. Well, the center of our circle is 0, 0, since it's at the origin. All right, so that means instead of writing x minus 0 squared and y minus 0 squared, I could just write this. Which means I can just write it as 1. 1 squared is just 1. This is the equation of the unit circle. That's a squared right there. Is x squared plus y squared equals 1. Cool. Well, don't we know that x is the cosine and y is the sine? Awesome. So I'm going to rewrite this and replace it with sine and cosine. So this is cosine squared. And I'll write of theta just because we're talking trig now. Y is sine, so sine squared of theta equals 1. Awesome. This is the main Pythagorean identity. Let's think about why it's called a Pythagorean identity. Because of these right triangles in here. This is a right triangle. X, y. And so we have x squared plus y squared equals 1 squared, which is 1. So that's pretty cool. This is sometimes jokingly called the granddaddy of all trig identities. It's really the most important one. A lot of times when it's referenced, we say sine squared first. I'm not really sure why, but I will, write it either way. Obviously, we can, since we're adding, we can write them either way. Okay, so cosine squared plus sine squared is 1, or sine squared plus cosine squared is 1. This is what you should definitely write down. This is the main Pythagorean identity. The other two are derived from it. So anything in black on this page, you don't need to have written down. Technically, I'm just showing you where it's coming from. This identity in blue is the first Pythagorean identity. So make sure you get that written down, and then I'll start with a blank screen and get the other two. Okay, we have our main Pythagorean identity there. There it is in all its glory. Let's derive the other two. I'm going to show you how you don't have to memorize anything. So I'm just going to rewrite this main identity. And honestly, if you don't want to keep writing theta after each thing, I get it. It kind of annoys me. So I am just going to not write theta or x or anything. It's just easier. Okay, so here's how to derive the other one. So I'm going to start with our main trig identity here. Then what I'm going to do is I'm going to divide everything by cosine squared. That's legal because we're doing the same thing to every term in our equation. Okay, dividing cosine squared by itself gives us a 1. Here, you guys know that sine divided by cosine is tangent. So similarly, if both are squared, gives us tangent squared. And then 1 divided by cosine, okay, that's the reciprocal of cosine, right? That's secant. So similarly, 1 divided by cosine squared, secant squared. Cool. So I will write it with the thetas in there. Again, theta can just be x, it can be alpha, it just represents the angle. That's our second main Pythagorean identity. That is the one you see in your book on page 313 under Pythagorean Identities. They have it written as tan squared plus 1. Doesn't matter the order because we're adding. All right, here's what I'd like you to do. Pause the video and derive the other one by dividing everything by sine squared. Okay, if you were able to get that, great. If not, take a look at what I did in green. Started with the original Pythagorean identity, divided everything by sine squared, and then that gave us our third and final Pythagorean identity. Very cool. Those are the 3 that are in your book. These are just the 3 that you need to know. Here's the thing too. I really don't have this one memorized, nor do I have this one memorized. They're just so easy to derive, really. So as long as you remember this main guy up in blue, that's really all you need to know, and you can quickly just derive the other two, and it gives you really good practice for like remembering the reciprocals and stuff. All right, so I know there's a ton of identities. That's where we'll stop with identities. I'm going to do one example, but the reciprocal identities, quotient identities, and Pythagorean identities are the ones that you do need to know. So be sure that you understand why each one works, how to like derive these two, or if you're just a fan of memorizing, that's totally cool as well. I just think that the derivation process is helpful in not having to memorize something and rather learn how to just get it on your own each time. So we'll end with a Pythagorean identity example, and then you guys can start your homework. Okay, here's our example for the Pythagorean identities. I'm doing the guided practice 2B from page 313. We're looking to find cotangent and secant of some angle, only given that the sine is 1/6 and that the cosine is also positive. Note that this right here is necessary because we're trying to find cotangent, right, which is cosine over sine. And if we know the sine is positive, we need to know the sine, S-I-G-N, of cosine in order to know if cotangent's positive or negative, right? So since cosine's positive and so is sine, that means everything's going to end up being positive in this problem. We're in quadrant 1, basically. All right, we need to Well, think about what we need to find, really. We need cosine. We need to know what cosine is. The Pythagorean identity, the main one, relates sine and cosine and says that when we do sine squared plus cosine squared, we get 1. All right, so let's plug in what we know. We know that the sine is 1/6, and we don't know the cosine squared. And then 1/6 squared, remember squaring a fraction is just as easy as squaring both parts. All right, if you want to think about 1 in like a common denominator, you could write 1 as 36 over 36, right? If you want, you can write it like this. That's fine, because I can see into the future. In our next step, we're going to have to subtract this from both sides. And so having a common denominator might make your life easier. If you don't care to do that, it doesn't matter if you do that or not. So we'll subtract 1/36 from both sides. And then we know that our cosine squared, technically I could have written x here. Sorry for all of them. The cosine squared is 35 over 36. In order to find cosine, we have to square root. Now, when you're square rooting in an equation, yes, you need plus or minus, but think about why we don't need that here. Remember, we were told this. Cosine's positive, so we only care about the positive answer, so we don't need to include the plus or minus. All right, similar to squaring a fraction, square rooting a fraction is the same thing. You square root both parts, and that's the best I can write the numerator. So that's our cosine. All right, so here's some other information that we know. We know that the cosine is the square root of 35 divided by 6. Okay, I'm going to erase this part over here. And then we're able to find, since we know cosine, we're able to now find the secant. Okay, why can we find the secant? Well, the secant is the reciprocal of cosine. So our secant is the reciprocal of this. Now again, I'm not going to write 1 over this. 1 over just means take the reciprocal. So I'm going to write it as the reciprocal. We are going to rationalize by multiplying the top and bottom by root 35 so we can write our final answer properly. And that gives us 6 root 35 over 35. So that's our secant. We found it. Cool, so we're halfway there. The last thing that we have to find is the cotangent. Let's think about how we can find that. The cotangent is just the sine divided by, cotangent is cosine divided by sine. Okay, so let's do that. So the cotangent is the cosine over the sine. We know both of those. So the cosine is root 35 over 6. The sine is 1 over 6. Root 35 over 1 is just the square root of 35. Cool. So we found both of them. Some of these can get a little complex, but it's really good if you can find both the sine and the cosine. Like I said at the start, those are your building blocks, really. So if you find sine and cosine in a problem, you're pretty set. You can find basically anything else by either their reciprocals or dividing them. So if you're stuck in a problem and you need to find a trig function, one of those 6, get sine and cosine. Get your building blocks set, and then you're pretty good to find everything else. All right, let me tell you what your homework is, and you can get started. Your homework is here on the screen. I cannot stress how important that, since we're doing e-learning now, how important it is for you, if you haven't been doing this already, to take control of your own learning. This is truly like the best college prep that probably you're going to have in your whole high school career, really, is staying at home and learning through YouTube videos. I will say that's how I learned a ton of stuff in college. And like knowing that you're doing something right is so helpful. It's also helpful if you make an error and you're able to see, okay, did I check this answer? I made a mistake. Let's see why, and let's self-correct. So this is what you're responsible for. A lot of those are odds. Check them. Okay, once you do it on a sheet of paper, please upload it to the Dropbox on Blackboard, and I will give you a grade for it. That's really how this is going to work. And then if you do have questions, remember you can talk to me through Zoom during my office hours. All right, guys, good first video. I'll try to keep them about this length, 20 minutes or so. It's still only half of class time, so that's awesome. Look at that. All right, take care, and I will talk to you soon.